All right, so these are the notes for solving systems of linear inequalities. Before we get into the linear inequalities, we're going to talk about slope-intercept form, which is y equals mx plus b. For graphs, what does the m stand for? The m stands for slope, and that's going to be your rise over your run. And really quickly for your rise, you go up if it's positive, and you go down if it's negative. And then when you run, you always run to the right. So that should always be positive on the bottom. For your B, that is your y-intercept. And that's where you begin on the y-axis. All right, for word problems, M, the slope is going to be called your rate of change. And your y-intercept again is where you begin on the y-axis, so it's the starting value. All right, H is going to stand for horizontal. So your horizontal line is going to be y equals some constant, and it's going to be a line that looks like this. And vertical is x equal. You're looking for a vertical line, and that's going to look like this. So horizontal and vertical lines. Those are the equations that make them. All right, and just to look at graphing them. So here we see our slope is 1, and we need that to be a fraction, so we put it 1 over 1. And our y-intercept is 3. So we begin on the y-axis at 3, and my slope is positive 1. So positive, recall, tells you to go up, and then always to the right, and in this case 1. So we go up 1, right 1. So just refreshing your mind. So to go backwards, we go down 1, left 1. So this is how you graph a line if you have forgotten. And there's my graph. All right, for the second one, my slope, it's already solved for y. So in front of x is negative 1/2. And my y-intercept is positive 6. So we begin at 6 on the y-axis. My slope, it's negative 1. So instead of going up, we go down 1, and then we go to the right 2. So starting at that y-intercept, we're going to go down 1 and then right 2. Down 1, right 2, down 1, right 2. And that's as many as I can fit on there. So now I connect my dots, try to make a straight line. And there's my graph. Okay, so now we're going to get into how to solve systems of linear inequalities. So the first thing it says is going to be a system of linear inequalities. Is a set of 2 or more linear inequalities in the same variables. An example is shown. So this would be equation 1, equation 2, and equation 3. And as you'll notice, they are all solved for y, and they are all in slope-intercept form. The only thing that changes is this symbol now. Instead of an equal sign, it is now an inequality sign. A solution of a system of linear inequalities is an ordered pair that is a solution of each inequality in the system. So an ordered pair would have to satisfy each equation. So each equation would have to be true. So our first example here is just asking us to test whether these points are solutions or not. So tell whether each ordered pair is a solution of the system of linear inequalities. So in order for this to be a solution of these linear inequalities, it must satisfy all of the equations. So we'll start with y is less than 4 times x. And so first thing we'll do is we'll change this as x and this is y. So 0 is less than 4 times 1. 0 is less than 4. That is true. Now we're going to go with y is greater than or equal to x minus 1. So 0 is greater than or equal to 1 minus 1. 0 is greater than or equal to 0. That is true. And for the last one, y is less than or equal to 2x plus 1. So y is 0 is less than or equal to 2 times 1 plus 1. So 0 is less than or equal to 2 plus 1, which is 3, and this is true. So for letter A, yes, that point is a solution to the system. For letter B, once again, this is x, this is y, so we plug into the first one. So y is less than 4x. So negative 8 is less than 4 times negative 2. Negative 8 is less than negative 8. That is not true. It could be equal to it, but it's not greater than itself. So this one is automatically no. It is not a solution to the system of linear inequalities. All right, for the next thing, it says graphing a system of linear inequalities. So graph each inequality in the same coordinate plane. So you can see there are 3 equations being graphed. Find the intersection of the half planes that are solutions of the inequalities. This intersection is the graph of the system. All right, so right here pretty much we can see that, so this one is being shaded below, or sorry, above. This one is shaded below, and this one is shaded below. So it appears, let me color this darker, is right here. This is the solution set right there. All right, so the way I graph these is if the graph is going to be solid and above is greater than, and solid, there has to be an equal bar. If it's going to be solid and below, it's going to be less than and an equal bar. If it's dashed and above, it's greater than, no equal bar. If it's dashed and below, it is less than, no equal bar. And those are the rules that I use. Okay, so let's go to the next one. So now we're going to take a look at graphing 2 of them. So for example 2, it says graph the system of linear inequalities. Actually, before I go back there, let's take a look here again real quick. For this one here, any solution is any point that falls in the triple shaded region, since there are 3 equations. So right here, a point here, that would be a solution, solution, solution. Okay, so solutions are points that fall on solid lines that border the solution set. So like right here where these 2 lines intersect, they are both solid, and it's right here where the the triple shaded region, so this would be a solution. When a solid and a dashed line intersect, this is not a solution because it will satisfy the solid line, but plugging this point in will not satisfy the dashed line because it will not be equal to it. And same thing over here, this would not be a solution. But anywhere along the solid line would be a solution up to this solid line, but once we hit this dashed line, these are not solutions. So just wanted to talk about that real quick. All right, so let's get to graphing it now. So for the first one, they are all solved for y, so I don't have to worry about doing that. So I'm going to do this one in blue. So recall that here my y-intercept is -5 and my slope is -2. So the slope, to make it a fraction, I always keep the top either positive or negative. The bottom is always positive. So -2/1, and the y-intercept is -5. So we begin at -5 on the y-axis, and my slope is -2, so I go down 2 from the y-intercept, and always to the right, so right 1. So down 2, right 1. And once I stop here, I go backwards. I go up 2, left 1, up 2, left 1, and I just continue that pattern until I get to the end of the page. Okay, now, from here I look at the inequality sign. Before we looked at this, it is greater than, so we shade above. So above is going this way, and it is dashed because there is no equal bar. So I'm going to make this a dash line. And the way I tell it's above is if I had somebody walking up here, they would not fall off this line. So if I had a little person just walking up here, they would not fall off. Okay. So I'm just going to put a couple of lines to show that I am shading above. And I will darken everything in once I know where since there's 3 lines, there should be a triple shaded region for a solution set. My next one I will do in purple. So here we have that our slope is 1, so we put 1 over 1 to make a fraction. And my y-intercept is 3. So we begin at the y-axis at 3. So 1, 2, 3. My slope is positive, so up 1 and right 1. Once again, we look at the sign. It does have an equal bar, so it is a solid line. And it is less than, so less than shades below. So I'm not going to shade this part in because there's no intersection here. I'm going to shade right here where there is intersection. So right now I can see that my solution set is appearing here and not up here. And for the last one, we have this here. We can see that our slope is once again 1 over 1, and our y-intercept is -2. So we begin at -2, 1, 2, and my slope tells me to go up 1, right 1. It is a solid line because there's an equal bar, so I connect all my dots. And it is shaded above because it's greater. So now I'm just going to shade where it's all connected. So we can see that my solution set is every point that is in this area on this solid line up until here, and on this solid line up until here. At this point, this is a dashed line, so this from here to here, these are not solutions. All right, for example 3, we're going to do the same thing, graph another system here, but notice these ones are not actually solved for y. So the first one, 2x plus 3y is less than 6. So first thing we're going to do to solve for 3y or y is we're going to subtract 2x from both sides. 3y is less than, I cannot take away 2x from 6 because they are unlike terms, so minus 2x, and that's a positive 6. And to isolate the y, I divide everything by 3. So we get y is less than -2/3 x, and 6 divided by 3 is 2. So this time I'm not going to write the slope and y-intercept, I'm going to just visually see it. So this is my y-intercept at +2. And -2/3 is my slope, so that's telling me to go down 2, right 3. Continue that till I finish off the paper. To go backwards, I go up 2, left 3. And there is no equal bar, so it's a dashed line. And it is less than, so I shade below. All right, and once again, how do I know it's less than? Because if I had somebody trying to walk up here, they would fall off, so that's less than. The person could walk up here, so that's greater than, that's above. That's what I do, just in case you're curious. Next one, we'll do in purple. It is already actually solved. So I start at 4, my y-intercept. My slope is -2/3 as well, which tells me from this point to go down 2 and right 3. Then up 2, left 3. It is a solid line, and it's greater than, so I shade above. And so I shade above. Now at this point here, I can tell that it's going to be a no solution. And the reason why I can tell that is because in order to have a solution here, all three regions must intersect. But these two go in opposite directions, so they will never actually intersect. Even if the third one happens to intersect both of them, not all three will intersect in the same spot, but we'll just continue this. So the last one I'll do in this green, so I'll solve it first for y. So we add the 2x. So y is less than 2x minus 2. So we start at negative 2. We go up 2 and over 1 to the right, up 2, right 1. And we just continue that pattern. Down to left 1. It is a dashed line. And it is less than, so we shade below. So as you can see, there is no place where there is a triple shaded region. Like over here, we can see a triple shaded region. There was right here. Here, we have a double shaded, single, single, and single. So this one is actually going to be no solution. Now, just a quick reminder, really fast, is that this symbol, inequality symbol, will actually flip around, like go from less than to greater than, if you ever divide by a negative number that's in front of this variable of y. So if I had like negative 3, when I divide everything by negative 3, this sign would flip. So hopefully you recall that from Algebra 1. All right, last we're going to write a system of linear inequalities based off of this graph. So what I'm going to do is I'm going to start with the form y equals mx plus b, and then I'm going to change this inequality symbol to either greater than, less than, greater than equal to, less than equal to, based on the graph. So the first one I'm going to do, and I'll try to color it as I go through, I'll do this one because it appears it's just a vertical line. So this is x because it's a vertical line, so it's x. Now this one's different. Greater than is usually above or below, but in this case it's kind of like a number line. So I can see that the shaded region is not going to the left, but it's going to the right. I can see it shaded all over here. So going to the right is greater than. This is a solid line, so it's equal to. And it's equal to the value that it crosses on the x-axis, so negative 1, negative 2, this is negative 3. So my inequality for this vertical line is x is greater than or equal to negative 3. For the next one, we will do this line right here. So I know it's going to be y equals mx plus b, so I'm going to start with y. It is a dashed line, and the shading is not above, the shading is below, so that's less than. All right, now I'm going to find my slope of m. So I like to start at a nice point, so we have this right here, this value of positive 1. So what that tells me right there is that my y-intercept is 1. And from here I find another nice point where these lines intersect, so I see that the lines all intersect there. So I can go down 1 and then to the right 2. So down 1 is negative 1, and then to the right 2 is positive 2. So when I plug this negative 1/2 in for m and this 1 in for b, we come up with the equation y is less than negative 1/2 x plus 1. All right, and then for my last equation, we have this one right here. Once again, we start with y. It is a dashed line, and the shading is now above, so greater than. We're going to find my slope and my y-intercept. So once again, the y-intercept, you just look at the y-axis. It looks like it crosses at negative 1, negative 2. Now for my slope, I start at the y-intercept since this is a nice point, and I try to find the next one where it intersects right here. And I go up 1, right 2. So that is up 1 divided by right 2, so 1/2. So now we plug it in here, so y is greater than 1/2 x minus 2. And that completes the notes.